I'm Mike Willey. I am the Vice President of Technology for Paragon Innovations. We're a TTI company.
And I'm Mike Wilkinson, the General Manager and Vice President for Paragon Innovations.
So Mike, one of the things that I wanted to talk about with you is one of my real passions, and that's low power design, because I feel like that particularly for what we know to be the internet edge, the IoT edge, low power is really critical because often there are no easily available electrons where we're getting ready to do IoT. We're often in places where we have to be solar powered or battery powered or doing other kinds of energy harvesting to get any power at all to run what we're doing. And I thought it'd be fun to talk about that.
I think it's a great idea. Let's talk about that, one of the first early low power devices that we've done.
So we could talk about the dog collar. That's a great one.
Oh, exactly, the very first one.
Yeah, so we did one of the very first dog collars, and it's kind of interesting because one of the things that we learned with the dog collar is that we had cellular radios on that back in a time when cellular radios were not what you and I would consider low power.
Exactly.
And so what do you think were some of the most important considerations when you're designing for low power?
Well, several things. I think number one is if you don't need it, turn it off, for God's sake. I mean, I think people go into sleep modes and stuff when if you don't need it, turn it off. You need to have a defined reason to turn some circuit on in the product and then turn it off when you're done.
Yeah, that's true. That's true. And one of the little pitfalls that you also have to be careful about is the attack of the zombies when you turn things off, because there's a mode that you can get into without going into all the technical details that you can get where you're powering things off of I/O pins instead of power supplies. Yeah. Very bad for power consumption.
Absolutely.
And occasionally blows up chips.
Exactly.
Yeah. So
well, some things are like, even the GPS and stuff, when to turn it on, when to turn it off. GPS, as we all know, is a very power hungry thing. Even today, where the most modern iPhones, you're going down the street, if you want to drive from here down to Austin, your battery will be dead by then, even on a good cell phone. So so we need to turn things off. Like GPS, get a fix, and then turn it off, and then you can get a fix later, unless you absolutely have to be tracking your whole way like in a traffic application on your phone.
Yeah, so what sorts of information do you use to figure out when you can turn things on and turn things off?
Well, I think there's some technical reasons to turn off circuitry that the engineers have to figure out, but I think the other is just use cases. Understanding the user, how they're going to use the product. Like the phone app, you need turn-by-turn instructions here in downtown Dallas, and so you can't turn the GPS off. You need constant fixes, because in 20 feet, you're going to make another turn. Mm-hmm. But if you got a product that's tracking something that doesn't move very often, or is a trailer, and you're just trying to find a asset tracking, getting a fix every hour or so might be the right answer, and it's all about use cases.
Yeah. Do you remember, I just was thinking about that funny story about Trey, one of our engineers, that was working on that first dog collar, and he was trying to figure out ways to save power and not use the GPS. And he came into my office and he said, Willie, I figured this out. What I'm going to do is that as soon as the dog gets outside the fence, I'm going to turn off the GPS and only take a GPS reading every hour. That way, if the dog's gone a long time, we'll be able to find the dog. And Trey's a hunter, and so he's a little different with animals than a lot of the potential customers for this. So I said, so Trey, let me ask you something. If you had this collar on your dog and you were sitting in a meeting with the president of the company and your phone went off and said your dog's outside of the fence, what would you do? And he said, well, I'd sit through the meeting, do the rest of my work, and when I went home at 5 or 6 o'clock, I'd go look it up on the phone and go find the dog. And I said, and you're never going to buy one of these products, are you? Well, I hadn't really thought I would.
Yeah, he's not a target customer.
Yeah, I said, the target customer is going, yeah, exactly. The target customer is going to tell the president of the company, I have a family emergency, and they are not going to walk to their car, they're going to run to the car. Yes. And so we talked to Trey about that, and he had to find some other places that we could turn the GPS off in.
Right. So I think, it's very important that engineers make some good decisions on splitting up power supplies and where they go on the circuits for the product, so you can turn things on and off independently, but also understand those use cases so that in the end you have a really low power device for the application.
Yeah, and it's sometimes important to come up with some innovative solutions. One of our tracking applications, we decided that we were going to use a special kind of battery because it had a huge capacity, and this thing had to run for months at a time without any opportunity to recharge, with a cellular radio that was periodically talking, and cellular radios consume a lot of power. This was before Cat M1.
Oh yeah, exactly.
And we had to, but we had these great high capacity batteries. The problem is that they couldn't support the current that was required to run the radio.
So we had to put them in parallel.
And we put them in parallel. And the other thing that we did was we ended up having to do capacitive storage.
That's right.
But we had to switch it because the capacitors drew current.
That's right. Big ESR.
Yeah. So it was, but that was fun. That was a fun project. But it's about understanding with low power too.
I think that's true. I think in the end, use cases, excellent engineering, and you can get a product to customers that are low power.
Yep. It's and it's. I remember, by the way, I remember you saying to a customer one time, holding up your iPhone and saying, "This is not a low power device."
Yeah. That's right.
Yeah, a low power device is one that will run for months, not days.
Cool.
So,
All right.
Mike, enjoyed this talk.
All right.